And additionally, one more, another envelope combination. Okay, now is this understood? Any more questions on this subject? Her şey anlaşıldı mı? Var mı kafanızda kalan bir yer? Yani yönetmelikler bunları yapın diyor, bu kombinasyonları. Bunu özellikle istiyorlar. Niye? Yani düşey yükleri azken depremin etkisi daha çok olabilir. Tamam. Bazen, bu da olabilir yani. Sen mesela G'yi %10 az fazla hesaplamış olabilirsin. Q'da hiç yoktur mesela, bina yeni yapılmıştır. Tamam. Bu da bir kombinasyon yani. Bina boştur veya boşalmıştır. Ve bazen bu maksimumu veriyor. Tamam. O yüzden bunlar tüm yönetmeliklerde vardır bu kombinasyonlar. Sadece Türk yönetmeliğinde değil. Now let's model this structure and then find periods, vibration periods, and then apply this earthquake loads. These are calculated from equivalent lateral load method. Okay, equivalent lateral load method or equivalent earthquake load method. And I'm not going to explain this because in order to understand this, the method, in order to understand this, the method that calculates these forces, you have to have some structural dynamics background. And I think in your university, structural dynamics is an elective course, not mandatory, right? It is elective.
No, structure one.
Some of you did not take structural dynamics course. Therefore, I am skipping this step. And we are going to define rigid diaphragms, and we are going to apply earthquake load on these diaphragms. And by considering eccentricity, we are going to define all these load combinations. All right. Now let's start. What are the span lengths? 5 meters and 4 meters. In X direction, 5 meters. In Y direction, 4 meters. And height, story height is 3.5 and 3. Okay. Cancel. File. Let's start here. File. New model. New model. And let's define grids. In X direction we have two grid lines. In Y direction we have two grid lines. In Z direction we have 3. But we forgot to select kilonewton meter, and let's restart. In X direction 2, Y direction 2, Z direction 3. In X direction span length is 5 meters. In Y direction 4 meters. Right? 4 meters. And in Z direction we have 3 meters. 3 and 3.5 actually. We can replicate this one also. We can do replicate. We can use replicate command. Okay, let's use replicate command. By using replicate command, generate the other story. Okay, select this 2 and this is 3.
Okay. 3.5 then.
Huh?
3.5.
Okay, this is 3.5, but after I replicate it, I'm going to move the joints downward, or move the grid line. Huh? Okay. Okay. Now we have two type of columns, S1, S2, and we have a beam. The beams, we have one type of beam. Now, for example, this is our S1, right? This is our S1, let's say, S1. And this is 50, right? 50 centimeter. and this is 25. This is 25, right? This is S1. Now, T2, we have T2 dimension and T3 dimension. Do you remember this?
Yeah.
For example, when I'm going to define section properties, frame sections, add new property, for example, rectangle. Now we have T3 and T2. Now for beams, this is always depth for beams. Beams. Depth is always this one, and width is this one. But for columns, these may change, okay, according to the orientation of the column. Okay. Now, T3 is this dimension which is perpendicular to 3 axis, T3. And T2 is this dimension perpendicular to 2 axis. Now, for S1 column, which one is T3, which one is T2?
3 is 25.
Huh?
25.
In order to find this, what do we need to do? Draw 2 and 3 local axes. Which one is 2 local axes? Which one is 3 for this S1? For example, I asked this in quiz 2, right? I'm going to ask this also in the final exam. Please understand this, how to find these local axes. Now for S1, this is XY direction, okay? This is XY plane, XY. For 3-dimensional structures, 2 is always parallel to what? X. 2 is always parallel to X. And what about 1? 1 local axis? It is always in longitudinal axis of the column, okay? In vertical direction for columns. For beams, in horizontal direction, 1. And what about 3 axis, 3 local axis? Yes, we can find it using right-hand rule from 1 and 2. Because 2 is always parallel to X. 1 is in longitudinal direction. And using right-hand rule, we can find third axis. But I am sure that now for S1, which direction is 2 local axis for this cross section?
50.
This is 2, right? This is 2 axis. And for example, if 1 is in this direction upward, if this is 1 is outward, like this one. This is 1. If this is 1. Or let me draw 1 outside. One is outside, outward. What about 3? In that case, 3 will be upward.
25.
This one. This will be 3. Now this dimension will be T2. In that case, this dimension will be T3, right? This one. T2, T3. Okay? Using these local axes, we can define correctly, we can define the orientation of this column correctly. Now, in that case, for S1, what will be T2? T2 will be 25. T3 will be 50. And S2 is similar. S2 will be, T2 will be 25, T3 will be 0.4. Now let's define these. First define material. Define materials. Add new material. And it will be concrete or add copy, let's say add copy of material, concrete. Weight per unit volume will be 25 kilonewton per meter cubed. And modulus of elasticity will be 30 e to the 6th, right? Poisson ratio is this one. Coefficient of thermal expansion is this one. You are not going to apply temperature. Okay, therefore this is not important. But 0.2 is Poisson ratio for concrete. What about steel? What is this Poisson ratio? Poisson ratio for steel. 0.3. And weight per unit volume is 25. This is our concrete. Let's write C25. Okay. Now define section properties. Frame sections. Add new property, rectangular. Let's first define beams. Beam. Material is C25. Depth is, what is the depth? What is given? Beam dimension 0.25 meter, 0.60 meter. Depth is this one, 0.60. Depth is 0.60 and width is 0.20. This is beam. And if you are going to make design for beam, you have to select this configuration. For beam, concrete reinforcement, you have to provide this reinforcement data. And these are rebar material. What is rebar? What is rebar? Reinforcing. This stands for reinforcing bar. It is the short of reinforcing bar. Rebar. And this is beam. Okay. This is beam. These are the material of, this is steel material, reinforcing bar, material of reinforcing bars. And design type is beam. Concrete cover to longitudinal rebar section. Concrete cover. What is concrete cover?
The distance from rebars to the bottom.
Yes, distance to the top of the concrete. Okay. What is in Turkish? What is called this in Turkish cover?
Gilaf. Gilaf.
Eh?
Gilaf.
Paspay. Cover means paspay in Turkish. Top and at the top and at the bottom they are 6 centimeters. They are taken. And if you choose this one, it is going to sub 2000 will give you the reinforcement ratios. Now this is okay, and beam is okay. Now, what about columns? Add new property, again concrete, and S1. Choose S1. Material is C25. Now for S1 you see the longer dimension is parallel to the larger dimension is parallel to X. Therefore, T2 will be 0.25, T3 will be 50, 0.50. T2 0.25, T3 will be 0.50. And this should be designed as column, okay? Concrete reinforcement column. Okay. Now, reinforcement configuration, rectangular. It may be circular also, okay, but this case, this time, this is rectangular. Clear cover to confinement bars. What is confinement? Confinement. Sargı. Sargı, etriye. Yeah. Confinement means etriye. Sargı donanısı. Clear cover to confinement bars, 4 centimeter. Number of longitudinal bars in 3 dimension and number of longitudinal bars along 2 direction faces. Now, along 3 direction face, we have 3. Along 2 direction face, we have along 3 direction face. This one is 3 direction face. This one is 2. Let's make this 2 as 2. Okay. Okay. Let's put 3 longitudinal bars here and 2 longitudinal bars here. Okay. And longitudinal bar size, number 9. This is bar size according to ASTM, okay, American standards. Number 9 is approximately 2.5 centimeters or 3 centimeters, probably 3 centimeters. Diameter. 3 centimeter diameter bar. And Confinement bars, etriyeler. These are number 4. It is 1.2 centimeter diameter. These confinement bars, etriye donatı çapı 1.2 centimeter. You can change these. You can choose whatever you want. And longitudinal spacing of confinement bars. Etriyelerin arası ne kadar alınır? 15 cm. It is given 15 centimeters. And number of confinement bars in 3 direction and in 2 direction. These are the number of confinement bars. And reinforcement to be designed. You also select this check. Okay. Now, we did something wrong. This is 3. Let's change these. Okay. Number of along 3 direction phase. Along 3 direction phase. Okay. Parallel to. This means that parallel to 3 direction. Okay. Therefore, parallel to 3 direction we need 2. Parallel to 2 direction we need 3. Okay. Okay. Now this is the reinforcement pattern I want to use. And this is S1. Okay. And we have another one. What is that? S2 similar to S1. Therefore, since S2 is similar to S1, I'm going to select this one, you see, add copy of property. Only the length will change. Therefore, I select this one, add copy of property, and S2, its name is S2, and this will be 0.4. This is 0.4. And concrete reinforcement is the same. Okay. Okay. Now we are all set. Now let's first draw columns. Okay. First draw columns. Here, S1, S2, XY is here, located here. XY is located here. And this one S1 and this one is S1. Now select S1. The column. Now draw S1. I draw S1. Always start from bottom to top, okay? Always try to make your columns from bottom to top. And this one is also this. Now change this one, S2. And this one is S2. This one is. Now these are, okay. Now select this beam. And this one is, okay. This one, okay. Okay. Now let's see extrude view. Why you don't see the extrude view? Why it is not working? I don't know. Sometimes SAP 2000 do this. It is not working. Anyway, we can find it later. Now we have another structural component. What is that? We forgot to model what? Slabs. We have also a slab. We must have a slab. Now, okay, let's see the local axis. Local axis. You see? Local axis is shown in black background better. You see these whites are local to axis. Whites. And these, I think you can't see this white, but these red ones are local axis 1. Whites are local axis 2. I think we can change colors. can change colors. What is background colors? Where is background? Okay, this is background. Now, background is now red. Let's select a gray background. Okay.
Hocam maviler Y oluyor değil mi?
Blue is 3. Red is 1. Red is 1. You see red. Blue is 3. White is 2. You see for horizontal numbers, 2 is always upward in Z direction. For horizontal numbers. For vertical numbers, 2 is parallel to X. Okay? Don't forget this. This is very important. Because you are going to orientate your columns, okay? You are going to locate your columns using this local axis. 2 is always parallel to X, 1 is in longitudinal direction, and for columns, and you can define local axis 3 using right hand rule. Okay. Now let's see now. Try to see it. Okay. Now what? Let's define slab. Define section properties. For frame section, we choose this one. For